Hi children, today we are talking about how can we prove root 3 is irrational or root 2 is irrational or root 5 is irrational. Sometimes 2 plus root 5 irrational or 5 into root 3 irrational. Now listen here. Root 3, if you can prove that root 3 is irrational or root 2 irrational, you studied last year. Rational plus irrational, that is irrational. Rational into irrational, that is irrational. And subtraction also same thing. So listen here. Root 3, prove that root 3 is irrational. We have to prove. That means maybe basic or standard, like this one question will be there. Class 9 also it is the rational number, irrational number. You know rational number. We can express P by Q form or numerator by denominator. Denominator is not equal to 0. P by Q form, Q naught is equal to 0. One more thing, P and Q are co-prime. That means no common factor is other. Now that concept we are using here, and one more theorem, that means P be a prime number. If P divides A square, then P divides A, where A is a positive integer. The theorem in class 10, theorem 1.3. Prime number P, if P divides A square, then P divides A. That also we are applying here. Two things we are applying here. That means one I told you, A by B, co-prime numbers. Now listen here. Let us assume to the contrary. Look here, we have to prove root 3 is irrational. We are assuming that root 3 is rational. Okay? Okay, if it is rational, root 3 is equal to A by B, where A and B are integers and co-prime. There are no common numbers, common fact is that co-prime number, underline that they are co-prime. Now listen here, root 3 is equal to A by B, so cross multiplication, A is equal to root 3B, root 3 into B, that is equal to A. Now squaring, here you can square, root 3 into B into B, 3B square is equal to A square. This equation 1. Look here, 3B square is equal to A square. Now that means 3 divides A. 3 divides A square. That or A square is the multiple of 3. This theorem we can apply. 3 divides A square because 3B square. That means according to the theorem, 3 divides A. If 3 divides A, we can write A is equal to 3C. A is equal to 3C. Integer A is equal to 3C. 3 times. Now listen here. Here 3B square is equal to A square, equation 1. So A is equal to 3C. That means from here substitute A square, that means 3C whole square, that is equal to 3B square. 3B square, that is equal to A square, that means 3B square is equal to A is 3C, 3C whole square. That means, understand this 3C whole square. You know 3C square is different, 3C whole square is different, you know that. 5 AB square, for A square B, and suppose for AB whole square. These all are different. 5AB square B into B, 5A square B A into A. 5AB square means 5 square A square B square. That is why here 3B square, 3C whole square. That means 3B square is equal to 3C into 3C, 9C square. That means B square is equal to 9 by 3. That means 3C square. We got B square is equal to 3C square. This is equation 2. I think it is clear. Now, according to the theorem, B square divides 3, then B3 divides B. 3 is dividing B square. Multiple of 3. So, 3 divides B also. Now, what happened? A and B has at least 3 as a common factor. Now, what happened? Here, 3 divides B and 3 divides A. That means A and B has at least 3 as a common factor. But this is contradictory to our assumption. What we did? Root 3 is rational number, that A and B are co-prime. But now they are not co-prime. They have at least 3 as a common factor. A by B, 3 we can see. Here B is equal to 3 divides, and here A 3 divides. A by B, at least we can divide by 3. One factor we can see. So from here, this is contradicted the fact that A and B are co-prime. So our assumption is wrong. Our assumption is wrong. What is our assumption? Root 3 is irrational number. That means our assumption is root 3 is rational number, but it is wrong because common factors we got A by B. That means our assumption is wrong. Root 3 is rational number, that is wrong. So root 3 is irrational number. That is the way we have to prove. I think you understood the concept. Now, suppose we want to prove root 2, root 5, root 7, irrational number. Same method we can do. Let it be rational number. If it is a rational number, we can express, that means root whatever be that, root x, that is A by B, root 5 A by B, root 7 A by B, but A and B are co-prime. That is important. Another one, if A square is equal to 5C, 5 something like that, whatever be that, A square is equal to 5C square, then A is equal to 5. Divide, that means we are dividing by square, we are dividing. So, the square root, the theorem I am again reading, P be a prime number. If P divides A square, then P divides A. Here 3 divides A square, so 3 divides A. 3 divides A. Now here also 3 divides B. So 3 is a common factor. Now last year we studied irrational plus rational, irrational into rational, irrational minus rational, irrational divided by rational, whatever be that, it is all irrational. That concept we can apply to prove. You can see in the question paper, one question you can see that, prove that 6 minus root 3 irrational. Prove that root 3 is irrational. Then we know addition according to the laws, addition or subtraction all irrational. That is the way. Okay.